Hey everyone, and welcome to this Threat Intelligence Explainer. I'm going to be stepping into the role of your lead security analyst today, and we're looking at one of the absolutely most insidious vulnerabilities hiding in modern web applications. I'm talking about DOM-based cross-site scripting, or DOM-XSS. Now, if you're responsible for securing enterprise environments, this briefing is definitely for you. We're going to break down exactly how untrusted data infiltrates the browser, and more importantly, how you can hunt it down. Think about the stakes here for a second. What happens when a user logs into their highly secure online banking portal, only to have that completely trusted environment execute malicious code against them? I mean, in high-stakes sectors like finance, the consequences of XSS are just catastrophic. We're talking about active session hijacking, where an attacker steals session tokens and literally impersonates the user, completely bypassing password security altogether. It is a massive corporate risk. Okay, here's our quick roadmap for this explainer. First, the threat of untrusted data. Second, the anatomy of DOM-XSS. Third, hunting XSS with a hands-on tutorial. Fourth, frameworks and third-party risks. And finally, enterprise defense in scanners. Let's dive in. Section 1, the threat of untrusted data. The entire foundation of this vulnerability really comes down to one critical failure, and that is trusting the untrusted. Let's look at what actually happens when unvalidated data infiltrates a web app. Successful exploitation leads to some really severe repercussions. Attackers can steal session cookies, which allows them to hijack active sessions and gain totally unauthorized access to accounts, even administrative ones. They can inject malware directly into the victim's browser, essentially turning their machine into a bot. They can manipulate vulnerable sites to redirect users to phishing pages or deface the website entirely. And, for a publicly traded company, that can cause immediate reputational damage and actively drop stock prices. Moving right along to Section 2, Anatomy of DOM-XSS. The crucial point we need to hit here is understanding exactly how these payloads execute. So check out this clear distinction. In traditional reflected or stored SSS, the server is basically an accomplice, right? It either reflects the malicious script right in the HTTP response, or it stores it in a database to serve up later. But DOM-SSS, totally different beast. It is a purely client-side execution vulnerability. The HTTP response doesn't change at all. Instead, the malicious modification happens entirely within the browser's document object model, or the DOM. To really visualize this flow, let's use a water supply analogy. Think of a DOM source, like location.search or location.hash, as a public water reservoir. Anyone can dump anything they want into it. It's completely untrusted input. Now, a DOM sink is the kitchen faucet where that water eventually comes out. If you pipe water directly from an untested reservoir straight to the faucet without a filtration plant in between, well, you get contaminated water. In the browser, if untrusted data flows from a source directly into an execution sink, you get malicious code execution. So let's categorize some of these dangerous sinks so you know exactly what to look for. Sinks like document.write, element.innerHTML, and eval are notorious execution points. If the flow of untrusted data isn't properly sanitized before hitting these specific JavaScript functions, they're going to dynamically execute the attacker's payload right inside the victim's browser session. All right, Section 3, Hunting XSS, Hands-on Tutorial. For this part, just imagine I'm sitting right over your shoulder as your mentor. We're going to manually hunt these vulnerabilities down together. Here's your practical step-by-step methodology. First, you inject a random, totally unique alphanumeric string into a source, like a URL parameter, for instance. Second, open up your browser's developer tools. Third, and Mrs. Key, you don't just view source, because that ignores any JavaScript modifications. Instead, you've got to search the live DOM for that specific string. And fourth, once you find exactly where it lands, identify the context. Are you inside an HTML attribute? Are you between script tags? From there, you just refine your input to see if you can break out of that context. Oh, and by the way, tools like Burp Suite's DOM Invader extension are incredibly helpful here for tracking these data flows automatically. Now, the complexity of your hunt really ramps up depending on the sink you're targeting. Testing HTML sinks is pretty straightforward because your injected string physically appears in the DOM. You can literally just search for it. But testing JavaScript execution sinks, like eval, much harder. The input doesn't necessarily appear in the DOM at all. To hunt these down, you have to use the JavaScript debugger, set breakpoints right where the source is referenced, and manually follow that value step by step as it moves through the variables toward the sink. It's like a giant puzzle. Which brings us to Section 4, Frameworks and Third-Party Risks. As we look at the modern web, we have to acknowledge that web development just isn't raw, vanilla JavaScript anymore. These common third-party libraries drastically alter your attack surface. Take AngularJS, for example. It actually evaluates JavaScript directly inside double curly braces on any element with the ng app attribute. If untrusted data lands in there, it executes. jQuery introduces entirely new syncs too. The $ selector can unsafely inject objects if untrusted data is passed to it, and functions like adder can unsafely alter DOM attributes, like changing a back button's link to a malicious JavaScript URL. These frameworks make the manual hunt significantly more complicated compared to older, raw JavaScript methods. Finally, Section 5, Enterprise Defense and Scanners. How do we actually defend against this at an enterprise scale? Let's wrap up our briefing with a look at strategic defense. Basically, you've got two main approaches for discovery. Manual code review requires deep inspection. It's fantastic for bypassing complex web application firewalls and finding those highly contextual bugs. The problem? It doesn't scale. Dynamic Application Security Testing, or DAST, automates this whole process. A DAST scanner crawls your target web app, builds out a map, and fires specially crafted payloads at every single entry point to monitor for execution. This allows for super fast discovery across massive enterprise environments. When it comes to best practices for your developers, the absolute golden rule is this: sanitize input on arrival. You have to filter that water supply before it reaches the sink. Use reputable libraries like DOMPurify to strip out dangerous tags. Avoid passing raw user input into dynamic HTML altogether. Make sure to use context-aware output encoding. And as a really solid backup defense, implement a strict content security policy, or CSP, using nonces or hashes. This tells the browser exactly which scripts are actually allowed to run. So, for the corporate risk managers out there, here is your professional workflow. Step 1. Verify the vulnerabilities using a safe proof-of-concept payload, something harmless like a simple pop-up alert. Step 2. Meticulously document the exact data flow from the source to the sink so your developers know exactly what to fix. Step 3. Select an enterprise DAS scanner that actually fits your specific technology stack so you can automate future discovery. And Step 4. Implement those sanitization and CSP mitigations we just talked about. I want to leave you with one final thought to chew on. You can map all your sources and you can sanitize all your known sinks, but as we saw with jQuery and AngularJS, the tools we use to build the web introduce their very own execution logic. So what hidden zero-day vulnerabilities remain completely dormant in the trusted third-party libraries your application relies on right now? Securing your own code is only the first step. Securing your supply chain is the ongoing war. Thank you so much for joining me for this explainer, and happy hunting out there.